This is our geometry review 1 through 45, part 1. Our top 5 questions that have to be covered for this class start with number 5. Write the definition as a biconditional. Okay. Biconditional is a conditional statement. Most of our conditional statements start with the word what? If. Okay, so a conditional statement has the word if. Halfway through a conditional statement, you have the word what? Then. You have an if and then statement in a normal conditional statement, right? If this is true, then this is true. Okay? But this is a biconditional statement. Does anybody know what words show up in a biconditional statement? If and only if. Okay? Is this going to let me write? If and only if. Now, where in the statement does that show up? Does it show up at the beginning? Does it show up at the end? Where does it show up? In the very middle. Okay? So if I'm looking at a question like this, right? An acute angle is an angle whose measure is less than 90 degrees. That's the statement we want the biconditional statement. A, an angle is acute if its measure is less than 90 degrees. Okay, is that a true statement? Yes. Is it a biconditional statement? No. Okay. An angle is acute if and only if its measure is less than 90 degrees. Is that a true statement? Is it a biconditional statement? Yes. Okay, but let's look at the rest. An angle's measure is less than 90 degrees if it is acute. Is that a true statement? Yes, but is it a biconditional statement? No. Okay, an angle is acute if and only if it is not obtuse. Is that a biconditional statement? Is it a true statement? Why is it not a true statement? Right, so at 90 degrees, it's not obtuse, but it's also not acute, right? So not all non-obtuse angles are acute, okay? So because I'm basically handing you the test, all right, I expect when you take the test to be able to do more than say B and write down the answer. Do you follow me? Okay, so I want you to mark, if and only if, and it's true. Okay? It's an if and only if statement, and it's true, therefore this is my answer. Okay? I will not be satisfied with you just writing down the answer. Are we clear? Okay, hope we're listening to this. All right. All right, after that we have number 9. 9. Number 9 is finding the area of a rhombus. The area of a rhombus. Does anybody know what the formula for finding the area of a rhombus is? Okay, I'm being told D1 times D2 divided by 2. Can you tell me, somebody besides Allison, tell me what D1 and D2 stand for? Diagonal 1 and diagonal 2, which is handy here because they actually label it like that, right? Okay, so diagonal 1 times diagonal 2 divided by 2. All right, I would dare say that most people get this question wrong because they forget to do what? Divide by 2, okay? How do I multiply D1 and D2, Chase? Is there a word for it? Not cross multiply. How do I multiply those two things? It's more complex. Distribution is necessarily a wrong term for it. Can anybody give him the more complete form of it. Not factoring, but foiling. So 2x plus 2 times 6x plus 8. Okay, Jordan, if you were going to begin to FOIL this, where would you start from? 2x and 6x. Okay, what is 2x times 6x? Okay. 2x times 8 is what? 10x. What's that? Plus 10x. Oh, it's 16. Two times 6x is what? 12x. And then what? 8 times 2 is what? 16. Okay, so now what? Combine what? Okay, what are my like terms? 12x and 12x is what? 24x, and then what? Is what? Okay, and what do I do at the end? Divide by 2. What do you get for an answer? 12x plus 16. I don't see that as an answer in here, and I can tell you at least 2 places where you messed up. Okay? The only reason I let it go is because, you know, we need to see how little mistakes at the beginning get bigger as we go throughout the whole thing. Okay? So 2x times 12x is what? Is it, or sorry, 2x times 6x is what? Is it just 12x? It's 12x squared. Okay? And what is 2 times 6x? Okay, you got the 12x here. What is 2x times 8? 16. No. What does this have? What does the 2x have? It should be 16x. Okay, so because we forgot to put in the x, right, we end up combining, we combine 16 and 16 instead of combining 16 and 12, right? Okay, the reason I let it go is not to like poke fun or anything like that. It's because we learn by our mistakes. We learn what kinds of things we might be prone to do on the test, right, if we're not careful. So a lot of times whenever I make a mistake and it gets pointed out, I am more apt to remember not to do that thing later. Does that make sense? Okay. So those were the 2 mistakes that I saw us make. Now let's go back and let's see how that changes things when we fix them. So now what are my like terms? 16 and 16x and 12x. So I still got 12x squared. What's 16x plus 12x? 28. Okay, you're doing it again though. Okay. All right. Now you might write it down, but if you don't say it, well, we might just as easily not write it down, correct? So don't forget those x's. Whenever I multiply them, I'm going to square them. Whenever I add them, all right, I need to include it. Okay, so what's our last step here now? Divide by 2. What's 12x squared divided by 2? Squared, 6x squared. What's 28x divided by 2? Okay, plus 14. Good. Plus 8. Okay, parentheses, centimeters squared because we're talking about area. Okay, is that the correct answer? Okay. We learned from those mistakes. Okay, and I'm guessing that several of us, we might have made some other similar mistakes, right? Did anybody get just 12x squared plus 28x plus 16? Did anybody get A for their answer? Yeah, because we just simply forgot to divide by 2, right? So hopefully on Monday, right, that's going to be something that we don't forget, correct? All right, so we're not going to forget to divide by 2. We're going to be careful when we're multiplying and adding like terms. We're not going to forget our x's or our x squareds. Okay, those are all things that we need to remember with this question. So don't assume just because your review is just identical to your test that you're going to do all the right things on test day. Now, keep in mind too, all that work that we put on the board, that needs to be your work on the test, okay? I may not go through your homework with a fine-tooth comb, but I will go through your test and I will DSA. I will do does not support answer wherever I feel like it needs to happen. Some of you, unfortunately, that kills your test score, okay, is the fact that we're not doing a great job of showing work. We can guess a right answer, we can select a right answer, but we can't explain how to get it, and that's really a problem because that's what we're trying to prove is we're trying to prove mastery. Okay, have you mastered the content? Number 12. Okay. All right, the circle graph shows the results of a survey by a bakery to determine which of its new products its customers preferred most. We want to find the central angle measure of the sector that shows the percent of people who prefer bread. If necessary, round your answer to the nearest tenth. So they are asking for, what is this angle? What is that degree measure? Okay, how do I go about solving this? What do you think, Cassie? I'm going to put this into degrees. Turn it into a percent. Okay, we have 29% there already, right? Set it up into a proportion? Sure. Okay, tell me about your proportion, Tiffany. Okay, so I got 29 up here. Okay, 29 over 100, so we have percent over total percent, right? Okay, so that's total degrees. Okay, and then what goes top right? Just not my percentage, but my unknown degree measure, right? Okay, so from here, cross multiply divide, if that's how you want to refer to it. What's 100 times x? 100x. It's 29 times 360. Awkward silences. 10,440. Okay, what's my final step here? Divide by 100 on both sides. Okay, 10,440 divided by 100. 104.4 degrees. Okay.
Would you put 0.29% times 360?
0.29 times 360. Yes, I would take that. Let's erase this and let's explain that idea for a second. Okay. So what you are saying is that what is 29% of 360 degrees? So you can do that right there, and that should give you 104.4 straight from there, right? So yeah, you can do the proportion if it makes sense, okay? Or if you want to look at it as just 29% of the total, okay? So percent, which change over to a decimal. You can't write it as just 29. You have to convert to a decimal, and it will give you the same number. So I would take that work absolutely, okay? Just make sure on a question like this that your work matches your answer, because if I see, something new, some new kind of work, I'm going to work out your work, and I can't tell you the number of times where I've worked out somebody's work where they said, they were multiplying or dividing two numbers, and their number comes out to the answer. But whenever I plug in their work, it comes out to a totally different answer. And so it was one of those, I knew the answer, and so I knew that there was some work, and so I wrote up some kind of crazy work that somehow comes out to this, but it actually doesn't. I'm lying about it, so be careful. Don't try to pull one over. You'll probably lose points on it. Okay, let's go back up to number 7. Number 7. Which of the following is a counterexample to the conjecture? All right, let's talk a little bit about counterexamples. What a counterexample should do 2 things. Does anybody know what the first thing that a counterexample should do? A counter example will what? Because one of the things that we've struggled on our tests over the last several tests is understanding counterexamples. Does anybody know? No clues? All right. So number 1, a counterexample will meet the hypothesis. There's probably other ways that we could say this. It'll meet it. It will agree with the hypothesis. Okay, it will prove the hypothesis true. Okay, does that make sense? All right, and then it will do a second thing. Does anybody know what the second thing that a counterexample will do? Counterexample. All right. Let's see. Let's try to think of some like real world counterexamples. Easy ones like if I made the statement, I don't know, I want to give you an if-then statement. If a plant is a tree, then it is an oak. Okay, that's an if-then statement. Can anybody think of a counterexample to that statement? If a plant is a tree, then it is an oak. Any thoughts? No. A counter example. So I want an example that is counter to what I just said. You're not creating a new statement. You're creating or you're coming up with an example that is counter to my statement. If a plant is a tree, then it is an oak. Perfect. Okay. So name me a tree. Pine. A pine tree is a counterexample to the statement, if a plant is a tree, then it is an oak. Because first, a pine tree is what? It agrees with the hypothesis of being a plant and a tree, correct? But it does what in the last part? It is not an oak, right? It disagrees. It will not meet the conclusion. It disagrees. It proves false the conclusion. Okay? So a counterexample will first meet the hypothesis, but it will disagree with the conclusion. Okay? So as we look up here at number 7, right, we are looking for a value for x that when I square it, it does equal 9, but is not 3. Do you understand? Okay, so I need a number that when I square it equals 9. Has to match this part. It has to agree. It has to be true here. Okay, but when it gets over here, it has to be false. Okay, go ahead. -3. -3 works. Okay? So let's discuss why these different numbers don't work. Okay? X equals 9. Is 9 squared equal to 9? No. So because it disagrees with the hypothesis, it cannot be a counterexample. Okay? So in our verbal example, if a plant is a tree, then it is an oak. I couldn't bring to you my uh, my wife's caravan, right? Why not? Why can't I say, here's my caravan? That's a counterexample because it's not a tree, right? You follow me? Okay. So it has to match the hypothesis. I have to give you a tree to look at. All right. What about x equals negative 9? Doesn't work for the same reasons, right? Okay. What if I showed you a fern? Okay. Why isn't a fern a counterexample? Because it's not a tree. It's a plant, but it's not a tree. Still doesn't work. Okay. What about C? X equals 3. Why does that not work? Because it makes the conclusion true. So one of the things I can't do is I can't show you another oak, right? Is an oak a counterexample to if a plant is a tree, then it is an oak? And I'm like, okay, here's an oak tree. Well, that just proves me right? It's not counter. You follow me? Okay? So what we're left with is something, negative 3 times negative 3 is 9, right? It matches the hypothesis, but negative 3 is not equal to 3. All right? So do we understand this a little bit better now? Okay. So what I'm expecting is more than just on the test saying x equals negative 3. I want you to bring out these two things. Okay? I want you to say x equals negative 3. Negative 3 times negative 3 does equal 9. Okay? But negative 3 is not equal to 3. Therefore, it meets the hypothesis. It does not meet the conclusion. Can we do that? Okay? If I'm handing you this to you on a silver platter, I expect more on your test. Okay? Are we clear? Okay? And Bella, I don't know if you're working on your review or how much of this you're paying attention to. Okay, good. All right. All right, so let's erase this. All right, number 14. Okay, this is a question we've seen before. Using the information about John, Jason, and Julie, can you uniquely determine how they stand with respect to each other and on what basis? So your first statement, and this I want a picture for. Okay, I want you to draw a picture. Statement 1, John and Jason are standing 12 feet apart. Okay, what do I do first? Okay, draw a line from John to Jason. So who's this? John? Where should I put Jason at? To the right? Okay, his body's not quite. It'll work. This is Jason, correct? Okay, now what do I want to do? Draw a line from here to here, right? How long is that line? 12 feet. Okay? Statement 2, the angle from Julie to John to Jason measures 31 degrees. Now what? Put who at the top? Like about in where? Just in between but above them? Okay? So, okay, there's Julie. All right, now what? Draw a line from her to John. Okay? Put 31 degrees. Okay? because from Julie to John to Jason, so this angle right here is 31 degrees. Okay? Now what? Let me read the next statement. The angle from John to Jason to Julie is 49 degrees. Draw a line from Julie to Jason. Okay. Okay. At Jason, put 49 degrees. Okay, that's this angle right here. Okay. Do they create a unique configuration based upon how they're standing with each other? Is it specific? Okay, specific enough we could probably we could use math to determine exactly how far John and Julie are standing apart and exactly how far Jason and Julie are standing apart, and we could even use math to determine exactly what the degree from John to Julie to Jason is, couldn't we? Yeah. So we could go on and we could find out all of the other parts of this triangle if we wanted to. All right. So you guys said that there is a unique triangle, but using what? Angle. Okay. So I'm assuming that we're referring to, let's say, this angle, and then this side, and then this angle, right? So using angle, side, angle. Okay. So if you can draw the picture and label it, okay, then that's the work that we need. Does that make sense? All right. Again, a lot of these questions are questions we've seen before. So what should be happening is the more tests we take, right, we should actually be scoring higher because we're seeing a lot of those same questions pop up kind of again and again, so we should be getting better at some of them. All right, so those are your top 5 missed questions. I'm going to go back up to the very beginning, and I'm going to let you guys kind of determine what it is that you want to ask questions about. Okay? Question number 1. Does anybody need to see question number 1? Okay, I'm just going to scroll. What about question number 2? No, we know how to find a midpoint? Okay. Question number 3? Okay, so let me write this one up. So we're going to look at question number 3. Classify the triangle according to its sides and angles. So I want to make a list. Okay, sides. How can I classify a triangle by its sides? What 3 classifications for a triangle do we have by the side lengths? Isosceles. Okay, what does isosceles mean? 2 sides what? 2 sides congruent. Okay, what's another classification? Scalene. What does scalene mean? 0 sides congruent. Okay, what's another one? Equilateral. What does that mean? 3 sides or all sides. Okay? All right, what about angles? Okay, there's acute. What does acute mean? How many? Okay, 3 sides less than 90 degrees, right? Okay, what else? Right? What does right mean? 1, oh, this is wrong here. This is, okay, 3 angles less than 90. Let's see, 1 angle. Ugh, I got to learn how to write. Angle equals 90. Okay, what else? Obtuse. What's that? 1 angle greater than 90. Okay? All right. What is this? Let's go by its sides first. By its sides, it is what? How do you know? The tick marks, right? right? Because the little tick mark tells me the sides that are congruent, and this says all three sides are congruent. So it's equilateral, right? Okay? Is it obtuse or acute? Acute, how do you know? Okay, and the other, I mean, there's multiple different ways that you could look at this. Okay, so, but what I want for your work, okay, is if you're going to write equilateral, you're going to tell me three sides congruent. Okay? And it's going to be acute, okay, because all three sides are less than 90 degrees. Okay? I don't just want equilateral acute. I want you to tell me what the term equilateral means and tell me what acute means. Can you do that? Okay. Do we have down our different descriptions here, or do you need a second? Okay. I don't think that they is. Okay. So let me erase this now. What about number 4? Classify the polygon. How are we classifying it? Does anybody know? By the number of sides, right? So the one on the test is probably going to be a different number of sides. Are we pretty familiar with how, what the different names for the different sided figures are? Or do we need to go over that quickly? 3-sided figure is a, 4-sided figure is a, no, no. You're being too specific. You don't have enough information. Quadrilateral, good. 5-sided figure, pentagon. 6-sided figure, hexagon. 7-sided figure, 8-sided figure, octagon. 9-sided figure, nonagon. 10-sided figure, 11-sided figure, hendecagon. 12-sided figure, dodecagon. 13-sided figure, 13agon. 14-sided figure, 14agon. 15-sided figure, 15agon. Okay, all right. It just keeps going like that. Once you get past 12, everything is just that number agon. Go ahead. Okay, number 2, you need to know the midpoint formula? Okay. All right, number 2, the midpoint formula. Can somebody help us out here? X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Now I want to go up here. Bella, what is X1? Which one? The one on the left or the right? The left. So this is X1. What's X2? No. 5, okay? Because that's a really easy mistake to make, right? We'll just go X1, X2, Y1, Y2, but that's not how it works, right? It's XY, XY. Okay, what is Y1? The other -3, and what is, Y2? Okay, so we're going to get -3 plus 5, which would be 2. 2 divided by 2 is 1. Okay, then we're going to get -3 plus 7, which would be 4. 4 divided by 2 is 2. Right? Does that make sense? Okay. All right. All right. So, and I'm going to go ahead and say that we've covered 4, although we just did it verbally. Okay. We've done 5. How are we doing with things like corresponding angles, alternate interior, alternate exterior? Do we have those things down? Okay. Okay. So I'm less concerned with the question itself as much as you understanding what corresponding angles are. Okay. So corresponding angles. Okay, I want lists of corresponding angles. What angles are corresponding in this diagram? 4 and 8. Okay, do we see that? Okay, let's see, who gave me that? Allison? Somebody else give me another set of corresponding angles. 3 and 7. Good. Somebody else? What's that? 5 and 1. Okay, there should be one more. 2 and 6. Okay. Now what you see here, improved, let's see, do we have any of those? We got 4 and 8, right? Okay. Now, let's say they give you a totally different question. Do you guys know enough about alternate interior angles to identify them? 2 and 8. Good. Angle 2, angle 8. Okay. Give me another one. Angle 3 and angle 5. Okay. What about alternate exterior angles? Somebody else. Jordan, give me a pair of alternate exterior angles. 1 and 7. Angle 1, angle 7. Okay. Ashlyn, can you give me another pair of alternate exterior angles? He gave me 1 and 7. 4 and 6. Okay, good. Angle 4 and angle 6. These angles, if congruent to each other, prove that those two lines are parallel. Okay? So that's just a little bit of a refresher recap on that. All right, we'll say that we've done number 6. Okay. Do we have this down? Okay. So with this, I would have the picture, because if they change the number orders, right, that's going to change which angles are congruent to each other, right? Okay. All right. Let's see. We've done 7. What about 8? Are we good with 8? Which statement has a true converse? What does the term converse mean? What am I doing if I have a converse statement? Changing a hypothesis and conclusion. Explain you what you mean by change. Flip. Okay, so if the original statement was if A, then B, the converse of that would be what? If B, then A. So as I look at this question, one of the things I need to do, right, with each of these, okay, so this is my work for this, right? I'm going to write the converse of each statement and write next to it true or false, okay? Look at A. What's the converse of statement A? If what? All right, so I would start by saying if two, okay, so we have to have our subject. Our subject is 2 angles. So if 2 angles are not supplementary, then they are complementary. What do you, okay, so I'm going to write the converse statement. And I'm going to write next to that whether it's true or false. Is that true or false? False, okay? All right, what's the converse of statement B? If, what's the subject? No. What's the subject? If an angle is what? A right angle, then it measures 90 degrees. Is that true? Yes. So I'm going to write the converse of that statement and write true next to it. Okay. What's the converse of statement C? Jordan? What's this? Tell me what the subject is first. No. Just the subject. We're going to leave if. Okay. If is not the subject. A polygon. So if what? If a polygon. No, because we're trying to find the converse. If a polygon. Say it again. If a polygon is a parallelogram, then it is a rectangle. Okay? Is that true or false? False. Why? Could be a square. Okay? Could could just be a parallelogram, right? Not all parallelograms are a square or a rectangle. Okay. D. Chase, help me out here. What is the subject in statement D? 2 lines. So I'm going to say if 2 lines what for the converse? If 2 lines intersect, then they are perpendicular. So I'm going to write next to that what? True or false? If 2 lines false, right? Because they could intersect at all kinds of different angles, correct? All right. So do we understand what the expectation here is? Okay. So I want the converse statements listed. All right. That was question 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've covered about half of them, maybe even a bunch of them that you got right, but you might get wrong on the test if you don't know how to show work for them. Okay? So we're going to go ahead and stop there.